Okay, hi everyone. I'm Divya Jain. I work with Game Time, which is a ticket selling platform in San Francisco, and I am big thanks to the droidCon online organizers for having me back. Also, a big thank you to everyone who's out there today, who's here, and I really hope that everybody is keeping safe and healthy. So let's get started. So today I'm going to talk about WorkManager, which is another Jetpack library, which acts as a super clever delegate for scheduling all your deferrable background tasks. So let's get started. Okay, so how many of you identify with this? Especially these days, we are all working remotely. So imagine being bombarded with multiple tasks at the same time, deadlines, no delegates, no assistants. I'm sure it sounds familiar, which is our everyday stories. This one here looks super energetic, but I'm sure at one point of time, like everybody else, it wears you out. And the reason that I started with this slide is because it is the same thing with the Android main thread. The Android main thread, as we all know, has lots of responsibilities. It handles all your UI events. It coordinates user interaction, also user events back and forth. Also, it responds and receives all your different lifecycle events. And we all know the golden rule of Android, which is basically if there are, it's a lot more limited resources. So which means that if you're doing a lot more things on the main thread, it leads to either a slow or a very hung up screen, or also the most dreaded application not responding alert. Also, there might be various criterias that if we want to perform a task, there might be various criterias that we need. For example, we might need the task to be performed immediately, or we might need some sort of completion while the user is interacting with the app for sure. So if the app shuts down, then we don't need the task anymore. Also, there might be a criteria where the service may need to be completed while the app is active or not. But there are other tasks like syncing, fetching something from the server, which is a very common functionality, or even when the app is not active. We also might want to schedule tasks for some particular time or for periodic intervals. And so anything which needs basically more than a few milliseconds, we need a background thread for it. Also, mobile devices has very limited resources. There is limited battery life, there is limited memory in general. So the idea is that we don't want to overload these resources with unnecessary consumption and instead be conservative with our approach. So now over the last few versions of Android releases, because of these, to overcome all these restrictions and these limited resources, a number of restrictions actually were introduced to ensure that the battery is optimized. There is elimination of unnecessary background processing and constraints on on the already existing limited resources, but still provide a good user experience. And some of the examples are these restrictions which were introduced with different Android versions. For example, the Android 6 had this DOS mode and app standby, which started with restricting background jobs, network accesses, and syncs for apps that were not used or stationary, and also put unused applications in the similar restricted state. Then with Android 7 came the DOS on the go, which further applied restrictions to CPU or network operations when the device screen is off for a certain time and not plugged in. So even in your pocket, even with the device in your pocket, you're on the go. Then with Android 8 came the limited background behavior, which imposed limits on the background executions like services or broadcasts and collection of user location services in background. And also it periodically released cached wake locks. And then with Android 9 came the app standby buckets, which basically let the system prioritize the app request for the system resources based on how recently or frequently the app is used, which further helped with optimizations. So let's say we are implementing a background task in our own app. Now we have different solutions available for us at our disposal, which is something like download manager, multiple threads, alarm manager, services, job dispatcher, or even the scheduling of the jobs through the work manager. Now, the idea with each of these solutions is that they have a specific capability or specialty which satisfies its own certain criteria that the task requires. So the question to ask here in order to choose the right solution for your background task is A, whether it is a big HTTP download. For example, you want to download big files. Then for that, we have the download manager, which will handle the necessary HTTP interactions. It handles the retries needed or handles the failures itself. Then if it is not an HTTP download, then the next question to ask is whether it is a deferrable task. So which means that if the task needs to be immediately completed, like in response to clicking of a button, or if it can be actually completed in some time, like the use case doesn't really care about the timing of the application, but it can be deferred to sometime in the future, which, for example, we want logs to be uploaded or some fetching of the data in the background, which we don't need immediately. So if it is deferrable, if it is a task which needs to be completed immediately, then we have a foreground service, because that is another way of telling the system that we need this task is the priority. But if no, then the next question, if the task is deferrable, then the next question to ask is if the task needs to be executed at a specific time, which is obviously the case of calendar events or the regular alarms that we have. So if it is a specific time oriented task, then we have the alarm manager. But if not, then if we have answered all these questions and we still come to this point, then we know that our solution is the work manager. Also, if the task is specific to a certain system conditions or dependent on specific constraints, for example, if you want it to be like if you want logs to be uploaded only when we are on Wi-Fi, or when the phone has enough battery, then the answer to all these questions is work manager. So basically, reiterating, the basis for why you would want to choose work manager over any other solution is A, if the task is deferrable, B, if it requires specific sort of system conditions, there is no particular time associated with the task. We want the task to happen at some scheduled at some time, but it's not very specific. Also, the main criteria is that we want reliable execution, which means we even if the device if the app has exited or if the device has restarted for whatever reason, we still want the scheduled task to happen, then the answer is a work manager. So let's talk about work manager in detail. So as I mentioned before, it is part of the new Android Jetpack library. And the basic functionality is that it cleverly and reliably schedules deferrable asynchronous tasks when the system conditions that are specified are satisfied. So internally, Work Manager itself for API versions 23 or above leverages the job scheduler, and for the older APIs uses a combination of broadcast receiver, alarm managers to optimize this background processing. Or if it has access to Google Play services and GCM, then it uses the GCM Network Manager. Now, with the new Android 10 release, the Firebase Job Dispatcher and the GCM APIs, which were supported earlier, are not supported anymore. So, but there is an extensive migration guide on the official documents to officially move to Work Manager for all your scheduling of these kind of tasks. Now, the other features are that there are wide variety of constraints that can be specified. as I mentioned, only you want the task to be only carried out when it is on Wi-Fi, or the device needs to have sufficient storage, etc. And I'll be talking about all these in detail in some time. Then second is that it allows robust scheduling of jobs that can be named, that can be tagged. It can the user can monitor groups of work, and it also works well with the restrictions like close mode that we talked about earlier. Or we also know that the task will reliably and for sure execute because the work details are actually persisted in an internal database, so which ensures that work details and states are persisted even if the device reboots for some reason, or even if the user exits the app. Now, if the task fails once for some reason, WorkManager actually offers flexible retry policies, which we'll also talk about in some time. It also allows you to chain groups of tasks sequentially or parallelly, providing conditions, which gives you the flexibility again to schedule based on different use cases. So over all these features, it has the ability to be used in combination with the other solutions like coroutines or RxJava in order to provide best optimization that is possible for all these background tasks. So now, once we have already asked the questions and we know that WorkManager is the appropriate solution to schedule my background task, how do I get started with it? So obviously, the first thing is add the WorkManager dependency onto your app, onto your project. Then create the task, configure the constraints which we want to specify for the task, and then hand the task to the system. So it's a simple 4-step process, and I'll talk about the details of each one of them. But starting with WorkManager it literally constitutes all these basic 4 steps, and the system then takes care of ensuring the optimization of how to schedule these tasks. So starting with the first one, which is adding the WorkManager to your Android project, basically add all these dependencies. And here you will see, as I mentioned, it is so robust that it actually provides you with the flexibility to work with coroutines, RxJava, GCM network manager support, and even writing your tests to ensure that the tasks are implemented in an efficient way. Now, the second, once we've added the dependencies, the second task is actually creating the background task, which involves further 3 steps: extending the worker class, overriding the do work method, and then finally getting the result. And here is a simple 3-line code for it. So we have an upload worker, which extends the worker class, overrides the do work method. So for example, if you want to sync to backend or upload images, this is where the logic for that will be implemented. And then finally, it comes back with 3 kinds of results. It can be a success, it can be a result.failure, or it can be a result.retry, which, as I mentioned, allows you to retry the task in case it failed for whatever reason. Now, worker, as we mentioned in the previous slide, defines what task to perform. Now, there is another object called the work request, which defines the how and when, and also allows you to define the various constraints for the task to be executed. So let's talk about the when first. There are 2 types of interval tasks that can be scheduled. As it says, the one-time work request, which is basically non-repeating, and it is created by using this one-time work request object. And the second one is the periodic time work object, which allows you to specify the intervals. So here, for example, the task of uploading, syncing the images with the backend is scheduled for every 1 hour. So also another example can be periodically sending logs to server or backing up your data, etc. So this interval for periodic ones that is mentioned here is the minimum time between the tasks. But also, if, for example, after an hour, if the constraints are not met or the system optimizations are not in place, then it can be further time before the task is repeated. Now, the minimum interval which can be defined is 15 minutes by default, And also, if the work with the latest version of WorkManager, if the work is sensitive to when it needs to be run, there is an option to also configure a flex period or a flex interval basically inside these intervals. So the whole idea is to provide you with as much flexibility as possible, but at the same time making sure that the constraints are met and the optimizations are in place. Now let's talk about how to add multiple constraints. Now we have something called the constraints builder, which allows you to create a constraints object, and it already has a huge list of specific constraints that can be defined. For example, we can have a required network type of metered, or we need this task to be accomplished only when the phone is with charging. So this is the way that we can through the constraints.builder we specify different tasks and hand it off to the system. The work manager will execute the tasks only when all these constraints are met, and if a constraint fails during the task will be stopped, and the work manager will wait for the system to again meet all the constraints before executing again if the specified policy is retry. So finally, we have created the worker task, defined the constraints, defined when to schedule the task for. The final step is hand the task off to the system. So Work Manager follows all the best practices for system optimization, again, to execute the scheduled task. So we basically schedule it using the NQ method, and Work Manager will handle all the optimization, but with the guarantee that the task will be executed when all the constraints are met. Now, how does the Work Manager internally execute? There is an internal task executor that handles all these enqueued requests. Now, what it does is it takes the work request info and saves it to the Work Manager database. Now, this database contains all the information and the statuses of each work request. For example, the current state, the input, outputs, constraints, etc. So now this is the thing that ensures the reliability that your work will be executed. So for example, if the user exits the app for some reason, or if the device restarts, the database acts as your cache where all the info is pulled out and the work is resumed or carried out again. Now, when the constraints for the particular work request are fulfilled, the executor tells the worker factory to create a background worker for the request, and then the default executor calls the do work method, which we specified earlier, of the worker to actually carry out the work off of the main thread in its own background thread. Now, also the work that is scheduled many times needs an input data. For example, if you're uploading logs, you actually need the logs to be uploaded, or for data to be backed up, or for images to be sent to the server, you need the image URI. Now, these input values are stored as key value pairs in something called a data object, which is then set on the work request through the send set input data method as shown here. Now, these data objects, one thing to remember about them is they should be small, and it also supports only primitive data types such as strings or any such array variants. And there is a maximum limit on the size of these objects, which is 10 KB. So if you need to, for some reason, specify bigger data, then you need that data needs to be stored somewhere in a local database and fetched every time you want that to be sent to the backend server, or to be passed as input to the workers. Now, also there might be times where you don't want to specify any constraints for the task, but you don't want the task to be scheduled or carried out immediately. So there is a method called the set initial delay, which basically allows the user to delay the initial task execution by a certain amount of time. And this can be set on the work request. And obviously this is possible only for the one-time work request. But if you specify this initial delay for a periodic work request, then only the first part of that periodic request starts with this initial delay. Now, if the work needs to be retried, there is as I mentioned, there is a return of the result dot retry from the worker. Now, this allows us to set the back off delay and also retry policy. Now, the combination of back off delay and the policy determines the actual retry config. So back off delay determines the minimum amount of time to wait before retrying the task execution. And the default is, I think, 30 seconds, if I'm not wrong. And the back-off policy defines how the delay is going to increase. For example, you can define it to be either linear or exponential over time for retry attempts. Now, also there is another feature which is available, which is called tagging of these tasks. Now, this allows you to operate on multiple tasks. So basically, you associate a tag with each of the tasks that you want to associate together. And then there is an easy method to identify all the tasks associated with a single tag. So for example, all tasks with the same tag can be canceled together using cancel all works by tag method. Or user can also get the status of all the same tasks that are tagged with the same tag with one request and observe the progress. So also that is possible by methods like get work infos by tag, etc. Now, every task that is carried out by the work manager goes through a life cycle and various states. So block state is possible in case of chained tasks that are chained together. And for example, the work enters the block state if a prerequisite work is not completed for some reason. Then enqueued is when all the constraints and the timings are met and the task is eligible to execute. Now, a task which is actively running is obviously in the running state. And then based on the result of the task, it either enters the succeeded or the failed state. And then for some reason, if the user explicitly cancels the task, then it enters the cancelled state. Now, the things to remember here is that the succeeded and the failed are terminal states. It can be only entered by one-time work request, because for periodic, it doesn't really make any sense. And also for the failed and the cancelled results, if one of the tasks is marked as failed or cancelled, then all the subsequent tasks which are dependent on this task through the chained reaction are also marked the same. Now, after the work is enqueued, you can also keep an eye on the status of the work through something called the work info object. Now, this work info object includes the ID, the tags, the current state, and also any output data which comes out of these tasks. They also have a corresponding live data version, which lets you observe the changes and then register a listener to respond to these changes. So basically, you can notify the user if the work has succeeded or failed based on this live data information, based on observing this live data information. Now, also with the latest WorkManager version, there is support for setting and observing intermediate progress of the work. So if the app is in the foreground while the work is being performed, the UI can observe this intermediate progress and allows the user to be more informed. Now, this progress is received through the data object which is very similar to the input-output key-value pairs. And so the work info we talked about also has another method called the get progress, which gives us the data in terms of live data, which we can again observe and keep notifying the user in case we need to of the intermediate progress. So the conclusion is that there are two methods available, which is the set progress and then get progress. The set progress is used to persist this progress to the database, which is also extensible to the Kotlin's coroutine worker object. And then get progress is used to react to intermediate progress information. Also, there are ways to retrieve this work info. As I mentioned, it can be through a work request ID. It can be through a work request, get work info by tag, and it also lets you it allows you to specify a unique name, which I'll talk about in a second. So these are different ways to retrieve this work info and observe the changes or the progress of the task. Now, to execute tasks, we might have multiple tasks which needs to be executed in a particular order, or they need to be executed parallelly, and also might be dependent on the previous task completion. So WorkManager allows you to chain different tasks together. And for example, a good example of this is, for example, if you're trying to process different images, so you can process these images by scheduling parallel tasks together. And then only when we know that each of these tasks has completed, we want to upload them to the backend server, we can chain them as a subsequent subsequent task to upload them to the backend. So here we have a method which is, in order to chain different tasks, we have a method which is begin with, and then the list of method allows you to specify tasks which can be run in parallel with each other. And then consequently, we can have then to have dependent work chained, which only runs after all the previous work in the chain has been completed. And again, going back to, so for example, if for some reason any of the parallel 1, 2, or 3 tasks fail or is cancelled, then all the tasks 2 and 3 will also be marked with the same status. Now, so also, so when these one-time tasks are chained together, the output of the previous task becomes the input to the next chained task automatically. Now, when the tasks are run parallel, it means that there are multiple outputs which needs to be merged to a single output for the next task. And this is possible through an input merger. Now, this input merger can be of 2 kinds. It can be either an overwriting one or an array creating one. Now, distinguishing between the two depends on how much data needs to be preserved, or if there is a flexibility enough that some data can be overwritten. So the overwriting one actually overwrites the keys in case of conflicts, which means that the task, the output can be actually overwritten, but the array creating one merges all the inputs and creates arrays if need be. So we can add, so there is a method called set input merger, which allows you to specify the kind of conflict resolution that we want. Now, to ensure that only one chain of work is being run at one point, WorkManager also allows you to specify a unique human readable and developer specified name to a task. Now, this is different from the IDs because it is not auto-generated and it is actually developer specified. And it's also different from a tag because they're associated at one time only with one chain. Now, here you see so we can use the enqueue unique work method to basically ensure that this is a unique chain of tasks that is happening. Now, the existing work policy is what is used to specify how to handle conflicts. If we have a chain sequence with the same name, but that is already running but hasn't finished yet. So again, there is either replace, keep, or append, which is, as the name suggests, the replace one replaces the existing one. The keep ignores the new request but keeps the existing one. And the append one actually just appends it. So if the previous task with the same name has completed, then this one is carried out. Now, this unique naming is suitable for tasks that shouldn't be enqueued multiple times. For example, if you're already sending logs to the server, you don't want to schedule another batch. So you can either choose to ignore the existing ones if the previous one is still happening, or you might want to use the append policy to chain it to the existing one. Now, this unique naming is also useful when you want to gradually build up long chain of dependent tasks, but each task itself takes a significant time. So now when we want to chain tasks with a specific name. Instead of using begin with, you use begin unique work with method. Now let's talk about canceling the tasks. Now under the hood, the work manager keeps checking the state of the work. If the work is already finished, nothing happens. But if the user decides to cancel the task, the state will change to cancelled and the work will not run in the future. Now, as I mentioned before, any work requests that are dependent on this work will also be cancelled. Now, if the work is currently running and the user decides to cancel the task for some reason, the work will also receive a call to a listenable worker.onStop method, and which allows the user, the developer, to override this method to handle any potential cleanups to avoid memory leak. Now, what can be the different reasons for stopping this work? Now, it can be either the user explicitly asked for it by calling the cancel work by ID method, or in the case of unique work, it can be we explicitly enqueued a new work request with the replace policy, so the old work will be cancelled. Or another reason can be that the work constraints are no longer met, or the system instructed your app to stop your work for some reason. Now, this can happen if you exceed the execution deadline. Each task generally in a work manager has an execution deadline of 10 minutes. So if the deadline is, if the task interval has increased, then this work is cancelled but scheduled for a retry at a later time. Also, so by default, when your app starts, the work manager configures itself automatically with default options. But with the latest version of Work Manager, it also gives you enough control to customize this configuration by using something called an on-demand initialization. So now, as the name suggests, with this kind of initialization, the Work Manager is created only when we need a task to be scheduled and not by default, which means that with every app restart, there is no Work Manager initialization, which means that there is an improved performance and the app starts with a lot more speed. So in order to incorporate this on-demand initialization, you can remove the default initialization from the manifest file, and the application class implements this configuration provider interface that you can see here, and then implements the get worker manager configuration method itself. So whenever you need work manager on demand, all that you need to do is call the work manager get instance, pass it the context, and the work manager is initialized on demand. Also, so as I mentioned before, a work manager's task limit at a time is 10 minutes. But again, in the latest version of Work Manager, there is support for long-running workers, which means this is Work Manager's way of notifying the OS that this process is long-running. It will go beyond 10 minutes and should be kept alive if possible. The example can be bulk uploads or image processing algorithms. So now the work manager ensures that this support is there by running a foreground service on your behalf, and also provides the option of providing configurable notifications to keep the user informed as to what's happening. And so for that, in the new versions, we have APIs like set foreground, which works well with listenable worker, or the set foreground, which works well with coroutine workers, which is basically a developer's way of specifying that this task has a higher priority and needs to be kept alive. Now let's talk about actually a real case, real world scenario. So since I work for a ticketing company, we come across this scenario all the time. So let's say that a user is able to buy tickets to an event, and it selects the quantity, selects the event, then proceeds to the checkout page. Now, the user is also able to apply credits to the order, which obviously updates the checkout cost. Now, for some reason, the user leaves the checkout page before confirming the purchase. the order technically should be reset to release the credits and not like make sure that the credits are available to the user at the same time. Now, each of these above steps actually needs a network API call, right? We have the save purchase, we have apply credits, and we have the reset purchase in case the user leaves the checkout page. Now, so basically the scenario here is that every time the user leaves the checkout page before actually purchasing it, we need to call this API called reset purchase in order to release these credits. Now, there might be a scenario where the user, this API is not called because there is no internet connection. So how WorkManager helps us to resolve this is by allowing us to schedule this task. And here you can see in the do work method, we are basically calling this, scheduling this API call called reset purchase, and also checking for ensuring that whenever we get the internet connection back, we need to ensure that this reset purchase is called and the credits are released. And if the response is successful, that's great. Even if it is not, then we allow it to specify a retry policy, because we want to ensure that the work is retried until it is successful. Now, there is another scenario. Let's say that on top of this, that reset purchase is scheduled by the work manager, but in the meantime, user reopens the app and also comes back to purchase. Now we need to ensure that the reset purchase is cancelled if there is a successful call to the save purchase API. So again, through the work manager, this is very easy, because all that you need to do is get that reset purchase by the tag and ensure that if the user, if the user comes back, then we can ensure that all the existing reset purchase tasks that are scheduled can be cancelled, and the user carries on with its own purchase. So basically, the whole idea is that the work manager allows you to handle these kinds of different scenarios and ensures that the work is done even when the user is not in a configurable condition, or if the user decides to exit the app, or the device restarts, or any other reason. So basically, conclusion is that work manager is super cool, and it is, again, reiterating all the reasons. Is it allows backward compatibility, it supports one-time or recurring tasks, it supports complex chain of tasks with inputs and outputs automatically handled. It provides the ability to set constraints, so we know that the task will be carried out only when these constraints are met. It follows best health practices for the system and the optimizations. And at the end of it all, it still guarantees execution, even if the app or the device restarts for some reason. So I think that's all from me. I am ready to take any questions.
Hi, Divya. I'm hoping you can hear me.
Yes, I can.
Okay, good. With all these crazy audio problems getting in, I had to log in over the phone. So, great presentation. I always think, as again, when I saw you in Boston in 2019 doing this similar presentation, I think one of the feedback that I heard from a lot of people is they very much appreciate how you make sure you let people know, particularly with what you're speaking on, when it's useful, when it's not useful, and also showing us kind of the power about grouping different tasks, chaining and things. So this was great to have you back again. I really appreciated you being here, especially on the short notice that we gave you this time. So you're always fantastic, though. Thank you. I'm going to get, Uli has already put Slido on the screen. We've got about 15 minutes, so I'm going to let you dive into the questions because we got people eagerly awaiting.
Awesome. Okay, so does it fulfill the work request even if we clear app data? I believe yes, but I'm not 100% sure. I'll make sure that I post a follow-up on Twitter about this because I know that it uses the internal SQLite database to basically preserve the app states and the different states in which the task is there. But I think I will definitely post a follow-up on that. The next question, does the system notify when the work starts? It depends on the priority of the task, and I believe that with the new work manager, it is possible to configure these notifications and basically observe the progress of the work, observe the status of the work, and allow us to notify the user by getting the work info live data object and ensuring that you as a developer are able to configure that notifications and keep the user informed as to what the status of the work is. How can we effectively run Work Manager even after device was rebooted, and what about waking up a device that is off? So I believe the answer to this question is, so even if we provide the necessary conditions, and if we I don't think we can manually run Work Manager, but basically with the way Work Manager allows us to provide like different configurations. So you as a developer need to just like specify the task and the conditions, and the Work Manager will ensure that the task is carried out even if the device restarts, unless like obviously if the constraints are met, and also if it is beneficial to like the system optimizations. There is no harm to the system optimizations. Can I run a Work Manager forever, something like scheduled polling? Interesting question. Yes, I believe you can, because unless and until you explicitly cancel the tasks, I believe you can run a Work Manager forever. But there is a guarantee that the work will be carried out. There is not a guarantee as to when, though, because again, it depends on the system optimizations. It depends on what the OS thinks is the higher priority tasks to be carried out. Can we use a precondition like for when permission is granted or revoked? I believe, I'm not sure about this one. I believe I'm not sure if there is a way to specify that as a constraint, but I'll definitely check out on this one too and make sure that this is answered as a follow-up on Twitter. How can a user cancel a task? Is there some kind of notification to let the user cancel the background task? Yes, there is. So basically, in your app, you can provide a way for, since you're sort of updating the progress and through configurable notifications to the user, you can, for example, you can provide a button which, or you can provide some way of user to respond to the notification, and and then in the app code just handle that user action to actually call the method cancel by the tag or by name, etc., to cancel the task that is going on. So this is all about ensuring that you are observing the task status at every time and ensuring that the user is informed of what the current status is. I tried the periodic Work Manager to work every 2 hours, but when it the first time to open the app, it launches the Work Manager right away. So that depends on if you specified any constraints or not, because as I mentioned earlier, so if there is no specific constraints specified for the Work Manager, then most of the time it immediately enqueues the task, and the app launches the Work Manager right away. So in order to overcome this, there are two ways. A, you set the initial delay, which will ensure that the first time the task is carried out, it is only after that initial delay. And the second one is the on-demand initialization of the Work Manager that I talked about, which lets you basically ensure that the Work Manager is not launched, but only when you need it to be. What are the different kinds of workers available? Can we extend and create a custom worker? If yes, how? So yes, there is a way to. So the different kinds of workers is there is a coroutine worker which works well with coroutines. There is a the GCM network manager, consistent one. There is one which is compatible with RX Java. So there are a bunch of them around here. And I also believe, yes, there is a possibility to create a custom worker to carry out a specific task. I can point as a follow-up on Twitter, I'll provide the link to how you can, there have been, there is a pretty good documentation around how to create custom workers. So I'll definitely point to that. Can we schedule a new task from within a currently running task? I believe you can through chaining, or even, again, it depends on whether we want that new task to be dependent on, if the new task is dependent on the current task. So if that can be done through chaining or by specifying new conditions. And that's what I feel. Might happen, not 100% sure. Can the work manager be used in every use case for which the sync adapter framework has been used until now? That's a great question. I think I believe yes, but again, I would definitely ask all the questions that if the use case requires the task to be deferrable, if it is asynchronous, if it doesn't need to be carried out at a specific time. So I think if you answer all those questions and go step by step, then you can then every use case can be determined to whether it's the work manager is the solution or you need to use something else. Is it a good idea to trigger a work manager to make a background API request remotely? Again, it is dependent on how you're using the background API request response, because if we want for a lot of use cases, usually the response is what we are dependent on in order to carry out further execution. So for that, definitely work manager is not the solution. But if it is a deferrable response that we need only in the background for some reason, then I believe yes, work manager is the right solution. Which one is better, periodic or one-time request? If I have to upload a list of image on server by taking the list of image, again, it depends on how do we need to frequently upload these list of images on server, and depends on the use case. Because, for example, if we know that this is only a one-time push to the server for a list of images in one bulk, then obviously one-time request is better. But if we need to, if the use case is we need to constantly, periodically upload these images, then periodic one works better. Why can't we use set exact in work manager? I am not sure what set exact does, but I'm assuming it is something to do with setting it at an exact time interval or something. And I believe the answer is deferrable, but again, I can go back and check what set exact is used for and then follow up on why it cannot be used. Which worker should I use for polling? Also, how should I post all the data to the UI? Yes, live data would be the way to go. Basically, live data is easily configurable to, the live data is easily configurable to get all the data and handle it the way you want. Which worker should I use for polling? So if you're writing code, if your code is 100% Kotlin, I would definitely recommend the coroutine worker, because that that's what I've been using, and I think it provides a very configurable yet efficient way of handling. But again, I would say it depends on the kind of use case and the kind of code that you're trying to write. So I am available on Twitter, always down for a chat. So DM me or tweet, and I can always provide follow-up answers in case I know I was not able to answer a bunch of them. So please reach out to me on Twitter anytime.